We will analyze the graph of a derivative in this video. I am Anil Kumar. Welcome to my series on curve sketching, a very important topic on calculus. We have discussed many test questions. One of them is right here before you. Here, we are given the graph of y equals to f prime x, means derivative. And we need to figure out answers for all these 5 things. So the question here is, the graph of y equals to f prime x is shown. Let me write down f prime x, derivative function, right? Question number 1, where can be the point of inflection on f of x? Question 2, determine interval where f of x is increasing. 3. Determine interval where f of x is concave down. 4. Determine values of x, if it exists, where the graph has local minimum. And 5 is determine value of x, if it exists, where graph has local maximum. You can always pause the video, answer, and then look into my suggestions. In case you want to learn from me, you can always send an email on the address given. Join our classes and excel.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Now, let's look into the solution of this particular question. We'll begin by answering the first two. We are given the graph of derivative of the function. That's kind of important to understand. This is not the graph of function, but its derivative. Question number 1 here is, where can be the point of inflection on f of x? Now, how do you find point of inflection? Now, at point of inflection, the second derivative is equal to 0. That is to say that from derivative, we have to sketch the graph of second derivative. Then only you will get the point of inflection. You get the idea? So since this is a cubic function, derivative will be what? 1 degree lower. Turning points will correspond to zeros, right? So we'll have a 0 here and another turning point, so another 0 here. Correct? So we have identified that these are the turning points. So at these turning points, we'll have zeros. Make a note, right? So turning points results into zeros. Okay. Now, in the first half, before that turning point, we know the graph is increasing. And that means the derivative will be positive, right? So derivative will be positive. In this interval, decreasing up to this point, right? And then it is increasing. So we have a 0 here and positive on this side, then negative. We have a 0 here and thereafter positive. Makes sense? So we could now sketch the graph as something like this. Correct? So that becomes the graph for the second derivative. And clearly, from this graph, we do have 2 zeros. So at these 2 zeros, we will have point of inflection. Perfect. So these are at x equals to 2 and 4. You get the idea? So these are the 2 points, the turning points on f prime x. which result into point of inflection. Okay. Now, let's look into part 2, which is determine intervals where f of x is concave down. Well, concave down is also related with the second derivative, right? So we have answered the first part. So where is the function concave down? You don't have to look at this. You have to look at that, which is the second derivative. So the function is concave down. Let me write down here. Question 2. Concave down. Concave down is when our second derivative is less than 0. So as we can see, the second derivative is less than 0 in this portion, correct? So that is to say, between these 2 points, which is 2 and 4, it is concave down, right? So in that interval, it is concave down. Is that clear to you? So with that, we have answered the first 2 questions. So first 2 questions are based on first finding the second derivative graph and then answering. Very important. Let's look into question number 3, which is kind of straightforward. Determine interval where f of x is increasing. We are given the graph of derivative, right? So increasing means where the derivative is greater than 0. So where is it greater than 0? Well, only in this portion. Do you see that? Very clear. Otherwise, it is negative. And therefore, there is only one interval where it is increasing, and that is from 5 to infinity. Many students get it wrong. They think wherever this graph is going up, they're increasing. No, it's the derivative, positive. And that's the only portion, correct? So I hope this is absolutely clear to you, right? In case of doubts, you can always contact me on the address given. Correct. Next move to question number 4 and 5, which is determine value of x if it exists where graph has local minimum. So how do you find local minimum from the first derivative? You do sign chart, right? You remember the sign chart? So minimum means it goes from negative to positive, right? And maximum means it goes from positive to negative, correct? So you see first derivative here is negative, 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 but here it is positive. So it does have a local negative to positive, right? So negative to positive means local minimum. Is that clear? And this happens at 5. So determine the value of x if it exists where graph has a local minima, it has minimum at x equals to 5, right? So the stationary points are the points where the function is 0. There are 2 zeros, right? But at this 0, it is not changing from negative to positive, and therefore this results in point of inflection as we did earlier, right? Now, let's answer question number 5. Determine value of x if it exists where the graph has local maximum. That means derivative should be positive and then negative, right? But we don't have that case. It goes from negative to positive. So this is none. Is that clear to you? So I hope you've understood how we have answered all the 5 questions. Now once again, when you're looking at the first derivative, let's be very clear. From first derivative, it's a good idea to sketch the graph for second derivative. All turning points will be zeros, right? Positive means rising, means this will be kind of like this. That is our second derivative. 1 degree lower, so cubic results into quadratic, makes sense, right? Then, where can be the point of inflections? These are always at zeros, correct? Determine interval where function is increasing. Function is increasing means that the derivative is positive. Clear? Determine interval where function is concave down. Concave down means what? That the second derivative is negative. So that portion, you get the idea. Determine the values of x if it exists where the graph has local minimum. That means it changes from negative to positive, right? So which is this point. And the graph does not have a local maximum. It never changes from positive to negative. Is that clear to you? With that, we come to an end of this particular video. So you have learned how do we analyze the first derivative graph, right? And get answers to all these questions. I hope you like and subscribe to my videos. Feel free to share your comments. And if you want to learn from me, send an email on the address given. Thanks for your time and all the best.